Good evening everyone. We are Team Rhythm presenting a project AirDrum. It's a real-time drumming system made using TinyML with Edge LLM based tutor. So traditional drums are very expensive, bulky and location dependent, and you need a human instructor to actually learn drums. Whereas in AirDrum, it's portable, you can use it anywhere, and it offers an LLM based tutor which is present on the device.
So, as you can see, we use the IMU sensor attached to the two drumsticks on both hands. First, we collected the data. The left drumstick is trained to run the snare and the hi-hat, while the right is trained to run the floor drum and the crash. Each Nikla Vision runs its 3-class classifier, and both of the inferences are then synchronized in real time, which makes it a much smaller model compared to CNNs. Now we'll move to the live demo.
Alright, so I have 4 sounds right now, and you can either see them. This is the second one, third, and this is the fourth. And I can play them at once as
well. So we also have an LLM drumming tutor. So let's run it here. So this displays so it's running on a local Llama 3.2 latest model. So it's running on the locally on the laptop. So this laptop acts as an edge device. So this provides something like a player-on sequence of beats based on the user input behavior. So based on the user's preference, it can play any song it wants. It can give the beats. So the user can easily look at this and play along. So the user can also adjust the speed and everything of this. So now we'll look at few of our results. So we have achieved 97% accuracy on training and testing data. There is also moderate inference latency in smooth and responsive drumming.
Is there a marker I want to explain something? There's no marker. Yeah, so we have a basic binary classifier which does this 4 things, right? But on top of it, what we recognized is we had one decision tree which said whether to play the down sound, whether to play the up sound, or whether to be silent. Alright? But we found out that it was continuously playing a sound. So we did some post-processing on top. The signal that we got was usually something like this of the variance. We were using a sliding window of the accelerometers and gyroscope data. Alright. So we took 50 as a window size and we calculated the variance, absolute variance. So we took the absolute variance of this, we added them up, and if you plot that on a chart, you'll see something like this. And our sliding window was 50. So if you draw a sliding window, it will look something like this. So whenever I did a movement like this, it goes into a function and it says play the sound. The advantage is that it's robust when I vibrate, but the downside is the sliding window after delta t moves to this place, and the variance is still positive, right? So we can either reduce the window size or we can just classify using this window, but use the current variance instead of the window variance. So that's what we did for post-processing. And the inference could be done either on the laptop or on the Nikla Vision itself. And we tried to do it.
So these elements are agents for all inference run directly on the Nikla Vision. This keeps latency and the running experience responsive, and because everything stays on the device, the system is private by design and it works fully offline, so you can use it anywhere. So these are the few IISc features we are trying to implement.
Thank you.
Did you start? This project is called AirDrums. where we are trying to replace drums with just sticks. So I think you might have already heard the sounds. So if you move the sticks, the IMU sensors catch up on the vibrations and then they play the required sound. Yeah, Varsha, please come.
This is the LLM tutor. So this gives out like notes and beats for any song we suggest. So this is the beats for Happy Birthday.
Yeah, now I can just, I'm not playing Happy Birthday, but I can just follow this along and then I can play the song. So for now, we have only 4 notes, but then we'll make it more granular and add more notes.
And the 4 notes are, on the right hand, on the bottom we have a kick drum, and on the top we have a crash, and on the left we have
It's playing, right?
Yep.
There's little latency, but it works. No.
This is not working, bro. This is not working.
Is there reverb, right?
Yeah, some noise.
I think it's my laptop.
Why is it so fast?
Make it slow.
Decrease the BPM.
Now decrease.
I'll decrease the BPM.